Hello, this is a video on how to determine overall enthalpy of a given reaction from enthalpies of formation of the individual elements of that reaction. You will normally be given the enthalpies of formation for the elements from either the book or the problem you are given. So it is products minus reactants, normally for every single reaction that you complete. NaCl is negative 410 kilojoules, 410.9 kilojoules. Na plus is negative 240.1 kilojoules. And Cl minus is negative 167.2 kilojoules. Then we add up the reactants and the products, and we get negative 407 minus negative 410.9. Yields 3.6 kilojoules per mole. And from this we can determine that the reaction is endothermic. And endothermic means that it has a positive enthalpy, and it also means that it is breaking bonds. For our next reaction, we have Ag plus Cl minus yields AgCl as a solid. And we do the same thing as we did before. We figure out, or we write down the given enthalpies of formation. So Ag plus is 105.9 kilojoules. Cl minus is negative 167.2 kilojoules. And AgCl is negative 127 kilojoules. Then we take products minus reactants like we did before. Negative 127 minus negative 62.2 gives us negative 64.8 kilojoules per mole. And since it's negative, the reaction is exothermic. Okay, so for our next reaction, we have a series of reactions, which is otherwise known as Hess's law, and we're going to add up the individual reactions to get the overall reaction, and we do the same thing for the enthalpies. First, we have to cancel the intermediates, which is CO2 and SRO. Then we can add up the individual enthalpies, which is negative 394 plus negative 592 plus negative 234. Which gives us negative 1220 kilojoules per mole. From this you can determine that the reaction, or the overall reaction, is exothermic. Alright, so for our next reaction we have another Hess's law problem, and this one is a little bit more complicated than the last problem. And a useful tip for Hess's law is to try and get everything on the same side in the final reaction. So the first thing we're going to do is reverse the bottom reaction. And when we reverse that, we just flip the reaction. So it puts 3H2 plus CO on the opposite side as CH4 and H2O, but it just puts 3H2 and CO as the reactants this time. And since we flipped it, that also means reversing the kilojoules, so, or the enthalpy. So we just make it opposite of what it already is. Then for the next one, we have to have two C's, so we have to multiply this reaction by 2. And we also do that to the enthalpy as well. So that gives us 2 C's plus 2H2O plus 2CO plus 2H2. Now we can cancel. So H2O cancels with H2O, 3H2 cancels with 3H2, and the 2 COs cancel with the 2 COs to give us our final reaction of 2 C's, 2 H2O equals CH4 plus CO2. And now we add up all of the individual enthalpies. So 2 times 131.3 plus negative 41.2 plus a negative 206.1 gives us total enthalpy of 15.3 kilojoules per mole. And from this, you can tell that the reaction is endothermic. Here's another practice problem for you to do on your own. This one is very complicated. Okay, so we got an overall enthalpy of negative 66 divided by 6, or negative 11 kilojoules per mole, which makes the reaction exothermic. And how we did that is we reversed the first reaction, which means we just flipped the reaction, and we changed the sign from negative to positive. Then on the second reaction, we multiplied it by 3, so we had to multiply the enthalpy by 3. And then for the third reaction, we reversed it and multiplied it by 2. So we had to change the enthalpy to the opposite of what it was, which is negative 19, and then multiply that by 2. And for our overall reaction, we got 6 FeO plus 6 CO yields 6 Fe plus 6 CO2. And then all we had to do was take 1/6 of that. So we added up the individual enthalpies, which was negative 47 plus negative 75 plus negative 38 gives us negative 66, and that's how we divided it by 6 as well. Now you should know how to use Hess's law and individual enthalpies of formation to find the overall enthalpy of a reaction.